then only we can say that now we are able to provide the protection. So if the threats are there, level of threats are there, number of threats are there, then the level of protection will be lower or not possible at the required level. So this is how we need to understand that really the security really matters or not. First of all, we have to understand as a security engineer. If you convince, then you can only convince to anyone else. Then we have to means try not to have any vulnerability, not to have any point of exploitation. First of all, we need to understand what is the vulnerability, what is the point of exploitation, and what are the threats so you can address them, you can eliminate them. So you make sure that there is no threat in your system. You make sure that there is no point of exploitation in your system. That is the most important point. So if you don't realize what security is and it really matters or not as a security engineer, then you will not be able to eliminate it. So that's why it is important. So if you feel that this is something which is the means increasing the cost, no, that's not the fact. And don't come up with the sense of feeling safer, but come up with the sense for being safer. And I hope that you understand what we mean. So in software engineering, like you all are the software engineering students. From the day first to the day end, all of the people, all of the instructors, all of the lecturers, all of the systems, all of the courses, they are teaching you how to build the software. No one is teaching you how to break up, how to breaking the software. What we mean that how to break up and why we need. So what we mean by for breaking it up, it means that when you are trying to control or face the challenges from the hackers, then you have to know about the weaknesses and think like them. So you can know that what could be the possible ways, what could be the possible things they can use and they destroy your software. Then only you will be able to safeguard your software to keep it in the safer zone. And then you will be only able to build your software that cannot be broken. But in the software engineering, we teach you how to build because that is the part of that code. That is not the part of that code, the how to break. That is not the part of that course that in case if suppose what could be the best ways that you can break the SDLC or break you can break the means come up to the system. But we teach you how to build, how to collect the requirement, how to follow the SDLC, how to means follow the different models. Okay, so you can do the waterfall model, you can do the best planning, you can do this, and you can do the testing, you can do the verification, you can go for the implementation, you can follow the SDLC. But at any stage, we are not teaching, or anyone is not teaching how to break the software. At what stage it could be, means you could be able to break it, which is the most important concept. You need to learn that as a security engineer. This is not the job of the software engineer. The software engineer job is that what we are teaching him, that he has to learn how to build, what step has to follow, how accurately, correctly components they need to be mapped, and how to make that software functional. If any attack on them, that's not his responsibility. That is not job. That is not his area. But that is the job of a security engineer. You are the one to inspect the code at each and every step and give them clearance, okay, this step is okay. So then they can move because they are coder, they are designer, they are developer, they are not the security guys. But you are security guy. You need to guide them. So this is how, means you need to think in a different aspect with a different angle. Then you will be only able to provide the security or to pinpoint the flaws which are there, or you can find out the point of the exploitation in the software. So if suppose the software contains the threats, the software have the point of exploitation in the code, it doesn't mean that software is not working. Maybe the successful software is working. Say for example, we can call an example about the different apps. Everyone is using the Grab app. Everyone was using the My Car app. So the My Car app, now they are announcing that uninstall your previous app and come up with a new app. Why? What is the reason? I hope you understand what I mean. So that is the job of the security engineer. And if the security engineer is failed to check all of the aspects, that's what we will discuss in upcoming all of the chapters, that how you can check at what stage what strategy you are supposed to apply. If we are failed, then it means the software engineers, project managers, everything, they will be failed. Like what we coded for a few of the applications. We just coded for the My Car app, and we already coded the different giant companies' applications and the giant companies' operating systems as well. So what do you think? They didn't follow the SDLC. They didn't follow the steps. They didn't write the code. Yeah, they did everything. And probably in some of the cases, maybe they follow the security standards provided by the security requirements provided by the security engineers. But what happened, maybe if suppose they fail to provide the right requirements, then what is the result? The applications are discontinued. So this is the most important point. So you need to be expert first, then you will be only able to protect your products and protect the systems. Going ahead, vulnerability. This is actually what we can call the informally a bug with the security consequences. It's not a formal bug. If it's a formal bug, then the coder or the software engineer can remove it. It is the informal bug. That's why, because he is concerned about the functionality. He is concerned about the functional requirement and non-functional requirement. That's it. But during that, if any informal bug is there, that is the vulnerability. Why we call that is the vulnerability? It means that is the honeypot, that is the point which can be exploited by the hackers and can be in and can be reaching to your software. So in other words, we also call this the design flaw. And how this design flaw is there? So that's why what we are saying are poor coding. So what we mean by the poor coding? Poor coding doesn't mean that it's not providing the functionality. Yes, it is providing a functionality. That's why the product is released. But then why we are calling this as a poor coding? We are saying this as a poor coding because the security aspects were not being monitored while the code was written. So then what will be happen? Then it will allow an attackers to exploit your software. So in case if suppose the software is going to be exploited, what will be the next? We can know that what will be the next. All of the efforts from all of our teams, they will be got ruined. So this is why the vulnerability, point of exploitations, threats, they are important and we have to take care about this. What we mean by the poor coding. So we try to have the few examples here. For example, allowing easily guessed passwords. This is poor coding. So we need to handle the strength of the password from the code. We may not keep that field, means the software is working, and we also provide the user cannot log in, but user has to log in to after providing registering and after providing the password. But if we don't enforce the software integrity, sorry, the password integrity, strength, and other things, then each and every user is not following this standard. Maybe the international password will be there 123457, and most of them they write their name and 123. So this is, if system is allowing to go with this type of the password, it is because of the poor coding. Because we didn't consider this aspect. The software engineer, he will not consider this aspect. This is the job of the security engineer. To pinpoint him. So what happened? Now, maybe the other design flaws. And the McGraw, they are mentioning that 50% of the codings are the mistakes and 50% are the design flaws. This what I mean by 50%? Means this is that based on the data, how many, what number of the softwares they means got compromised. So that study is explaining us based on those softwares, this is the issue. Now just imagine this is a small weakness, a small means a point which was not considered, then what could be happen to the whole software? So that is your job. So as a security engineer, you have to pinpoint, you have to understand first, then only you will be able to lead, or then you will be only able to guide to the coder or the software engineer or the project manager. Otherwise, they are concerned with the functionality. So from their angle, yeah, it is okay, it is functioning, everything is working. So what else is required? Customer is satisfied, yes, software system, software is working. But what happens after some time, it is going to be compromised. Why? The example is what we discussed right now. So we have to be very much critical. We have to design the security policies which can make sure and ensure about the integrity of it. Now, point of exploitation, you understand already. We already talked about the vulnerability and what is the threat. Exploit, what it mean by the point of exploitation or exploit? Exploit, it means any piece of software or any data, chunk of data or small data or any sequence of commands that takes advantages of what? Of the vulnerability. What is the vulnerability? Maybe because of the poor code. That's what we discussed. In an effort to cause what? Unintended or unanticipated behavior. So in other words, in simple words, we can say that if some vulnerability is there and someone is trying to use this vulnerability to enter in our system, that is known as the exploitation. And this doesn't have anything with the antivirus. You install antivirus. You may install firewall. You may install all of the equipments, security equipments. You may apply all of the policies. The software is working. But if suppose the vulnerability is there, so these all antiviruses and all these things, they cannot be able to stop it. So viruses, even this depended what type of the vulnerability is there, what type of the point of exploitation is there. So even few of them, they are exploited automatically by the viruses as well. Now, this is the most important point we need to understand. Then the threats. What is the threat? So the threat is actually a class of exploitation. in case if suppose we build the software, it contains 5, 6, 10 number of the point of exploitation. So that number of exploitation higher, it means it is the level of threat is higher. If there is no point of exploitation, zero level of point of exploitation, so the level of threat will be lower. And how there is no exploitation? It means that there is no vulnerability in our software. You will use the means assessments ahead. You will find that there are so many different patterns, manually, automatically, semi-automatic, and so on. But when you will use them to find out the vulnerabilities, you can do that even with your own softwares what you have written. And you will be amazed. How come this much number is there? So these are the concepts. First of all, as a security engineer, we have to understand. Then we only can realize that does security really matters? This will give us the answer about the question that what we started from. Yes, security highly matters. But how? If you say to the layman, security really matters, he will ask how. How we will defend him, how we will convince him, how we will means let him know and he can realize about that. So these are the most important point. That's what we just discussed, that while you are doing your software engineering, so all of you are teaching how to build the software. We're not teaching you how to break up the software. Okay, going ahead. Now, I hope you already understand the exploit, threat, vulnerability, and protection. Okay, so this is only a kind of recap just for you because we already discussed in very detail. So now you can understand protect against what? Exploitation. We have antiviruses, intrusion detections, firewalls, etc. But they can do up to some certain level. So we cannot trust on them. Because if suppose the poor coding is there, how the poor coding will be means saved by the antivirus, saved by the IDS, saved by the firewall. So protection against threats is what we need to use the forensics. We try to eliminate, we try to mitigate, and punish. That means provide the punishment. What we mean by the punishment, that we have to close those loopholes if possible. So how we can protect against the vulnerabilities? That is your job. Engineer secure software. So that is your job actually as a security engineer. So our job is related to the code, related to the development, related to the design of the software, related to the software in any terms, not related to the network as a secure software engineer. That is also the job of the security engineer, but that security engineer is different than what you have learned in the wireless networks. His job is about the network. His job is about the devices. His job is about the communication security. His job is about the different algorithms what he is or she is trying to apply for the encryption techniques. But they are not supposed to do anything related to the software. But here, your job is not that what we learned in the previous modules, but here your job is what it is related to the software itself, related to the code itself, related to the design itself, related to the implementation itself. So you need to understand the difference. That's why we said that the security is an umbrella term which has the several concepts. It's not the one thing or single thing or a single concept. So you know now, point number 3, everything initiated from the vulnerability. And who is responsible to handle the vulnerability? That is you as a secure Software security is what? Now, this is not any what we can say, something which we can define in black and white. We cannot say that something is in black art or something. Then what it is? It is actually to find out, finding the vulnerabilities, crafting the means point of exploitations in your software, endless and clever ways to break the software. Not to break the software for negative purpose, but to break the software to know the point of vulnerabilities, to make it safer and secure. And you, as a security engineer, you must have more knowledge compared to the hackers, because you know about design and development and implementation, and also you may know about how to break and then how to save. Those hackers who are coming, they have a limited knowledge about the point of exploitation or the vulnerabilities about your software. But they are not knowing about your whole code, about your whole routines, about your whole functions, what it is, where it is, how it is. If you make them safe, they will not get success over your software. That's why your level of knowledge required higher than the people who are trying to attack, or means what we can say, we can use a term, the more compared than the red teams. So you are responsible to knowing the security. Don't just leave it. Security matters. First of all, as a security engineer, we ourselves need to understand and equip ourselves. Then only we will be in a position to provide the protection. That's why we have to know and learn about that first. Now, software security is not a myth, but it's a reality. So if we say at the start that it's not a myth, it's a reality, so maybe you don't understand what we mean. You start maybe doing the brainstorming. But now you know what it is. Yes, it is. Okay. The otherwise, it's a reality. Otherwise, if we don't consider, we will be in trouble. So it is not a myth. It is a reality. And it goes equally for everything. For PlayStation, what we mean by PlayStation means for gaming, for network, for operating systems, for browsers, for everything. Now, it has a future. We cannot tolerate it. We cannot tolerate it. Then, one step ahead. Think for a moment. If suppose you are hired for a company, they already prepared a software. They already have something. You are not responsible, and no one was there while the software was built. Now they are hiring to you that they have a problem and issues. How you will overcome this? So we will discuss in the upcoming. So what is the risk management? How you will do the risk management? How you will make sure that the software which is there, it is okay, fine, working or not. So a lot of things. So that's why if you remember, we discussed in our first class that your job starts the time when requirement collection is started. Even before the time of design, you will do in the labs. You will do the one of the case study for very popular companies of motorbikes. You will see that how that popular company got lost just because of the means loopholes in their design. So these things are truly critical. Now, it is not a set of features like what we say that we cannot define what is the security. software security. It's not a black and white. It's not some sort of a definition. It is not some set of instructions. But now you can understand it, what it is from the different parameters and from the different aspects. So we cannot say it is the set of features. It is about the security of the software. And then the security of software is not a single thing. It's not a one component, but it starts from the design up to the implementation. And after the implementation, successful implementation, it is there, but then it goes to the network security and communication security and so on and so on. So you can find a lot of different tools, experts tools, the tools they are working based on the AI. They can help you to pinpoint, to understand, to find out the point of exploitations, weaknesses, where the code is written poor, and few of the tools are there. They can even suggest you that how to improve that. So you can provide that information to the coders. But the best thing is that before implementation, you have to make sure that these all things are fixed. So these different cybersecurity companies, but they are working in the corporate sector, how they are providing the help to the customers, they are providing the help in this way, that what you are learning. So the same thing you will be doing in your assessment, so you can see that how they are going to analyze, they are going to find out the weaknesses, and then how they are making a report, and then how they are suggesting these solutions to the corporate sector and the companies, how they are doing their business. They cannot do until they know better. So the same rule goes to us as well, that we have to learn before we call ourselves expert. Learn before we advise that what are the issues are there. Now, this is how we are supposed to educate them, guide them, monitor them, inspect them, and let them know how to properly use the software. Okay. What else? It is not a problem for mathematicians. If someone is start thinking this, okay, software security is only the problem for the mathematicians. What do you mean by mathematicians? Like suppose the cryptographic techniques, what we are applying, systematic cryptography, asymmetric cryptography. Then we go ahead and we say this is hybrid type level of the cryptography. So writing a cryptography, the most importantly, those people who are good in the mathematics. The mathematicians are expert for writing the cryptographic techniques. Like I hope that you already done with the computer network security course. AES and DES and triple D, RSA and DSA, how they are working. So this is not the only, or this is not the job for the mathematicians, but this is your job to pick and find out the poor code, the vulnerabilities, and keep remember one thing, that to come up with a proper design and complete the software by following the security standards is more easy and good and less cost, rather than the software is ready and deployed and then we start finding out the loopholes and the point of exploitation. That become a costly for us in all of the terms, in human resource, money, time, means all of the factors of the cost, they increase. So we need to understand it. I hope you understand the concept, that what I mean about that. So what next? It is software security is not a problem for just networking or operating system. So why you remember we are saying about the mathematicians. Now we are saying it's not a problem for the networking and operating system. So this is how he is trying to cover all of the other aspects that are actually link or related to the software security. Okay, so they are equally important, but they are important from the different other aspects. So we cannot blame, oh, okay, this is the networking part. As we discussed, we learn in computer network security, there is something different. We learn in means for the IDS, for the firewalls, there is something different. That's some, what we mean by the different, it is the different segment. Learn about security of the operating system, that is something different. You learned about the physical, means device physical security, that is something important and different. You learn about the cryptographic techniques, that is important but different segment. But this is very different. So software had a security problems long before we had the internet. So it means as a security, software security or software security engineer, you are supposed to make your product safer before it goes even to the internet. So these cryptographic techniques, these mathematicians, these computer network concepts, these physical device securities, these communication securities, they all come only in account after we deploy, when we make it part of the internet or the network. But the software security is more ahead than this. Means before it even become a part of the family for the network, these all things are sorry, these all things are need to be considered well before than that. Now we realize, you understand that it is the reality for everyone, and everyone has to face. So we must face, not just for the developers, but for all of the stakeholders. If it's going to be failed, it is not only for the developers, but the consequences will be faced by everyone, all stakeholders, from the developers, from the owners, from the security engineers, to the means end users and customers. So we need what? We need an ability. We need an means learnable mindset of the software engineers. We need an ability to prevent the unintended functionalities. We need to know it means how we can make the product safer for all stakeholders. We need to know how all components or all parts of the software can be become safer and good. That is the most important concept we actually require. So that's why, as we started, that we have to know more than anyone else. Then only we can provide the security. Our knowledge will be different, and as at the same time, the most importantly, that is, we are not responsible for writing the code. That's not our job. That's the job of the developer. But we are responsible for so many things that what we already mentioned. So that is the software security, and that is the role of the job of this software security engineer. The importance of the security. Just have a look in this example. One of the examples is there. What this example is saying, what we underlie, what happened in case, say for example, this example is demonstrating you a shopping interaction in which the user is free to specify the quantity of items to purchase and a total is calculated. So whatever the total user can calculate, this is only an example for your understanding. Say I'm a user, I can means consider the quantity, item A, I'm purchasing 3, and the cost for item A for each item is $10. So for 3 it is 30, so I can calculate and then I can write the total amount, because it is not handled by the code. The code should be handled, it automatically calculates and it doesn't allow me to enter any information. But what happens if suppose the program is written by this way? So I can calculate, okay, the products are 3 and each product is $10. So the total is $30. So while I'm writing the $30, okay, maybe the code is there, so code can check that it is correct or not. But what happens if suppose I just do what? I just write something, read the next line. The user has no control over the price variable. However, the code does not prevent a negative value. Even we don't give him the control. But if suppose the code is not preventing the negative value. So what happened? The $30 is there, but now rather to write or input the $30, I just put the minus sign with it and say minus $30. So what will happen? Do you know what will happen? This will happen that you will get the product, you will get that $30 credited in your account. So what happened? If an attacker was to provide a negative value, then the user would have their account credited instead of debited. So it means you are getting $30 in your account and also you are getting the product as well. This is just as one of the example for your brainstorming to understand how the security of the software is important. It's highly important. Now, if we see from the functional requirement and non-functional requirement perspective, this code is fine. If we see that either it is fulfilling the requirement of the customer, it is fine. It is working. It's providing everything. None of the people, they are knowing the tricks that how to go and write about the minus and something. But other than that, if you are providing the 30 in plus value, then it's okay. Product will be reaching to you and without any issue, the owner of the company will be getting the amount, which is the $30. No issue. But when the issue will come if suppose some of the red team person is just trying to use in this way. So now how you will stop it? How your antivirus will stop it? How your firewall will stop it? How your encryption techniques will stop it? How the other security aspects that they will be able to stop it? No? How you will stop it? Because that is the poor coding. That is the flaw in the code. So how you will be able to stop it? This is your job. That you need to make sure that values will be automatically calculated, as well as user may not have a chance to provide the negative value. So that part means as a developer, maybe he or she will not be aware about that. But that is the part of the security that which you are supposed to consider and guide that person who is writing the code for you. That is the most important point where you are supposed to consider. So I hope now from this simple example even you will be able to understand what it means. Okay. Now this example can give you the better understanding about that. Now there are the more details about vulnerabilities, about developer responsibility, about risk management, about secure software to understand it in a more way. And what about your engineering knowledge? So that you can understand, okay, how you can prevent from the vulnerability. So how you need to exploit avoidance. What is the developer responsibility? It is expert, but for writing the code, she is not expert for handling the security. Okay, for risk management, because at this stage you don't know what's the risk management. We will have a chapter about the risk management. So we are just trying to understand at this stage. So we will see that what is the risk management, how you can categorize, and how you can make sure how you manage the risk about your company, how you can enhance the security of your software, how you can be enabled to using the clever tools. What it means by the clever tools means those tools which are working on the expert system based, how you will be able to use them. Okay, so that's how you will find a lot of literature and everything. But the pinpoint is that you need to understand what is your job. And for that, you need to have more information compared to the others as well. Now we are reaching to the secure software, secure software life cycle. Okay. In the secure software life cycle, as we discussed, that we are supposed to follow all of the steps, even from the day first to the day end about this. So that's why we cannot go beyond this secure software or SDLC. So secure software development lifecycle. So what it means by secure software development lifecycle? This is the same SDLC, but we are looking now with respect to how to make it secure at all of the stages and at all of the steps. So how we can make it secure? We are supposed to consider all of the points, okay? All of the points which are very much concerns about that. Now, what are those points? You can make a security mistake at every step of the development lifecycle. So you are supposed to consider all of the aspects at all levels of the SDLC, even starting from the day first. Even you have to inspect about the requirements that are going to be collected by someone. So you need to see what the requirements are. So probably the people, your customer, they are asking for some sort of the requirements. Maybe they are containing the privacy violation. Maybe they become the vulnerabilities later on. Your customer are not expert. They are not knowing about that. But you have to know about that. You have to know about the design flaws. May not provide any plugins, may not provide any loopholes, may not provide any vulnerability in your design. You may consider the design part, the requirement part, the code part. Okay, you have to find out the vulnerabilities, point of exploitation in your code at all of these stages, including from this day of first up to the maintenance level. So you need to understand them. Well, we already discussed in thorough detail that what they could be, where they could be, how they could be. So you need to have a more knowledge than the software developer. So because if you are going to inspect his code, it means you have the knowledge that what he is doing. And after that, you have an additional knowledge to guide him. And after top of that, you have an additional knowledge that how could you be able to break the software, and then how you suggest him to save so you can be able to protect from the red teams. So at all of these stages, the deployment stages, maintenance stages, means code vulnerabilities, code levels, design flaws, means from the day first to the day end, you have to see for that. Security at each and every step, from requirement, from design, from the implementation, from testing, from deployment, from the maintenance, everything. Okay. Now you can see this one, security at every step. This could be a longer list, but we just try to come up with the few of the items to see that how it is. Now this, all of the options what we are mentioning here, they all are linked related to the security. Say for example, C to the maintenance, it is patching, regression, assessment, say for the testing. So the testing, with the software engineer's point of view, the testing and validation will be that how the system is working or not. But your testing will be penetration testing, okay, automated testing. So why you are doing these testing and everything? Because you are trying to know what are the loopholes, what could be the ways that anyone can break your software. At the time of implementation, you see, you are looking about the vulnerability taxonomy, input and output handling. This is the most important point. You're looking for the auditability. That is the most important points. So you can see from the provided details, these all items are related to the security, not related to the software development. So that's why we call this SDLC as the secure SDLC, because the same SDLC we are considering with respect to considering all of the aspects of the security. You can break the software security. Whenever we talk about the security, whatever the security, wireless network security, computer network security, or software security, or means any other security, always the base pillars are CIA, confidentiality, integrity. These are the parameters we consider, like whatever we are looking for all of these steps. The basis that we are following the standard of the CIA. So this is the most important. We are not going into detail for the CIA because that we already covered in multiple modules, and we know about these details. So we have to know that how we are making our software in line with the CIA, how we are using the, how we are considering the integrity of our software, and so on. So we know about the confidentiality. This is only for the reading, for your brainstorming, just for a recap for you, because the CIA we already covered in multiple modules, and we know that what is the confidentiality, what is the integrity, and what is the availability. So we are not spending this time on these slides, but they are there only for your recap. But in case if suppose any student who is new and they are not having the concept about this, and this is their first module for the security, so they can pinpoint and we can go in more detail. Otherwise, we are just trying to save our time to just bypass those concepts that what we already discussed. Okay, so that's also same for the integrity from the CIA. Again for your reading and for your brainstorming. Then about the availability, so same thing for your reading and for your brainstorming. Then we are coming for the security policy. That is also for your reading. So we know that the information security policy, which we call ISP, is important. We already discussed in the different modules that each and every user and the employee, they has to follow the standards of the security policy. If they don't, then it will be hard for us to maintain and manage the level of the security for the software. Security requirements. So the security requirements is a security features required by the system uh, that we have to make sure that they are the in line and they are in the safe zone. Means we may not accept any requirement which compromises the security. And but what happened about those requirements which are essential? The basic requirement means basic need of the software to be run are the basic demands. So then we are trying to keep them in the safer side, in the safe zone. So again, this is for your brainstorming. So identification and authentication. Again, this is the part of the CIA. So how we use them typically for the authentication and identification. Again, this is only for your reading purpose, so we are not spending time on this. But if suppose you have any concern or question, you can let me know. So the different proverbs are there. Defense in depth. For defense in depth, we need to follow each. If our software security is not intact, then the firewalls and all of the other aspects that what we already discussed, they will not be able to provide us. So these things we already discussed in detail throughout our lecture. So now the most important point here, that is the important concept. Fail securely. It's a very important concept. This is also your job. Fail securely. Say, for example, in any case, some unwanted event is going to be happen, and now the software is not able to restore. So then you have to guide to the developers that how safely and securely maybe software is going to fail, terminate the operation. Means that during the termination of the operation, it may not create some wrong information in the log reports or may not have open any vulnerability. So from where anyone else can exploit this one. So this is also the part in case we are not responsible while the software is only working fine during that part as security engineer, but we are responsible even in case if suppose software is going to be crashed or something is going to happen, then also it means fail in a secure manner. Detect and record. This is also we can guide them that how they can do that. So how we can detect the information, how we can record the information. So record the information that we can utilize it to further means improve security. So this is again for your reading, and then we are going for secure by default. So don't rely on your users. This is the most important point. Okay, that if suppose we rely on user and we consider that the users are the best user. What do you mean by the best user? Because the user are, you remember always we are saying that we have to educate the people how to use safely the internet even. So that is the one most important point. If suppose our users are not aware, they are not trained, then maybe so many difficulties will be waiting for us. Thank you very much. Any questions you need to ask, please let me know. And we're done from this. Now we may go for your attendance. I hope you understand now and you get the answer for all of the points that what we were means pinpointing and focusing about that. Yes. Any question, please let me know. Meanwhile, I just prepare for your attendance. Yes. So are you able to hear me? I'm just going to share the screen with you. And now today our attendance system will be different. It will be through the camps. So here we go. I'm just going to share with you the screen. Before that, we just stop now the recording if you don't have a question. So then we will go for attendance with the camps. So please keep ready your cell phones. I'm just going to share with you the screen to, for the code. So here we go.